This is just going to be a quick recap of graphing rational functions. Now, you've watched videos the last 2 nights on graphing rational functions, so I'm just going to quickly put it all together. I'm not actually going to graph anything, but it would be a good idea to follow along. Pause the video, see if you can kind of work ahead, because this should really all be review. So remind yourself that really ultimately when you're graphing rational functions, you want to kind of find these 3 key pieces. So the first thing is your x-intercepts are all of the zeros of the numerator. So whatever the numerator is in your function, you set it equal to 0 and solve it. And those are going to be your x-intercepts. Then number 2 says vertical asymptotes are at each real 0 of the denominator. So set your denominator of your rational function equal to 0, and anything you get solved for will be vertical asymptotes. And then number 3 is your horizontal asymptote is determined by the degrees of your numerator and denominator. So assuming p of x is your numerator and q of x is your denominator, if the degree on top, and that would be m, is less than n, then y equals 0 is your horizontal asymptote. If your degrees are equal to each other, like x squared over x squared or x over x, then you divide out the leading coefficients, and y equals whatever that is your horizontal asymptote, so some constant. And last but not least, if the degree on top is larger than that of the bottom, like x cubed over x squared, then you have to do synthetic or long division, whichever is appropriate, and probably it's going to work out synthetically for you to see what that end behavior asymptote is, which is kind of, the slanted asymptote. So really quickly, and I'm not going to actually graph these, but if you take a look at the first one, the first thing you want to identify is the degree on top is 0, and the degree on the bottom is 2, because it's a quadratic, so the degree on top is less than that of the degree on the bottom. So again, if you solve your numerator, there's nothing to solve, so that means I have no x-intercepts. If you solve your denominator, x squared plus 2, if I set that equal to 0, I'm going to subtract 2, and then I'm going to end up taking the square root of a negative, which is imaginary, so I also have no vertical asymptotes. And last but not least, because the degree on top is smaller than that of the bottom, y equals 0 will be my horizontal asymptote. So quick recap. And again, pause the video, see if you can kind of do the next one before I give away all the answers. So the second one, your degree on top is larger than that of the bottom, so I'll come back to that. But if you solve your numerator, so set that equal to 0, it factors down to x minus 3 and x plus 1. So your x-intercepts are going to be 3 and negative 1. Solve your denominator, and that's going to give you your vertical asymptote, so that's easy. X equals negative 2 will be my vertical asymptote. And then last but not least, and I'll actually show this one, but the degree on top is larger than that of the bottom, so you have to do division, and luckily, because I'm dividing by a nice linear function with a leading coefficient of 1, I can do synthetic. So if I set up my little box over here, the coefficients of this are 1, negative 2, and negative 3, and I'm going to divide by the solution of my denominator, which is negative 2. And then remind yourself you carry down, and then you multiply by negative 2, then you add vertically, then you multiply by negative 2, and then you add vertically, and remember that remainder doesn't matter, so y equals 1x minus 4, which I got from these coefficients, is my end behavior asymptote, EBA. Alright, then I'll kind of go through the last one quickly. Of course, if you solve your numerator, you're going to get 3 and negative 3, because it factors down to x plus 3 and x minus 3. So x-intercepts at positive 3 and negative 3. If you solve your denominator, that factors to x plus 2, x minus 2. So you're going to have vertical asymptotes at 2 and negative 2. And then the degrees are the same, so if you divide out the leading coefficients, 1 divided by 1, which is 1, will be your horizontal asymptote. Alright, and the last one, is, surprise, your special case, and this is what I call the HK model, because you have a rational function and then plus a constant. So remind yourself that h is -3, if I saw that right, and k is +2. That's whatever you add or subtract at the end. So h will give you your vertical asymptote. So basically x equals -3 is going to be your vertical asymptote. And then your horizontal asymptote is whatever your k value is. So y equals 2 and x equals -3.